In this particular video, we're going to be looking at 4-step problems. Here we're going to start introducing the kilogram. I wanted to bring this back and just make one quick note. Here, we want to make sure that whenever we're looking at calculations that involve grams going to grams, we don't confuse the conversion factor between a mole and a gram with going from kilo to kilogram. So we're going to try and keep those two separate, and then from there is where we're going to go and start with the 4-step process. Calculate the amount of kilograms of aluminum nitrate produced by 157.3 grams of aluminum chloride. So the question is asking us for the amount of kilograms of a particular compound within our balanced equation. So that is what we're going to write at the very, very end. Kilograms of aluminum nitrate. So that's what we have. The question also gives us a piece of information that is 157.3 grams of a compound. So remember, we're always looking for a number, a unit, and a compound. Those three things tell us what our initial point is for our dimensional analysis. So that is what we're going to write at the very, very beginning. So we have grams of aluminum chloride. So we're going to do our little dimensional analysis. And as usual, we're going to see that our unit and our compound do not match what we're looking for at the very end. And for that reason, this initial unit and compound has to be brought down so that we may cancel it. So we are going to write gram and aluminum chloride at the bottom. So based on our resources, whenever we have gram at the bottom of our setup right here, the only thing that may go on top is 1 mole. So we are going to write mole. We're talking about 1 mole of that same compound. So we're still talking about aluminum chloride. So then we stop and we look at what we have. We know that these two are going to cancel down. So we would be left over with mole of aluminum chloride, but that does not equal to kilogram of aluminum nitrate. So that tells us then that this right here, this particular unit needs to come down to get canceled. So that's what we're gonna do, mole of aluminum chloride. So when we have mole at the bottom, we have options. We can do a mole over a mole so that we may change, so we can have a switch, right? Change of compound. We could also have atoms, molecules, or particles, or we could even do grams. So remember, your number one priority is always to make that change. And we're gonna make that change at this point because we get mole at the bottom. And the question is asking us for a different compound, so we must do a switch at some point. So we're gonna write mole of that new compound, and that new compound is aluminum nitrate. So that's what we have. And again, we see that our units don't match. So that tells me that this top part also needs to be canceled again. So we bring that down. So now we have mole of AlNO3. And again, we have the same options. We can make a switch. We could do one of atoms, molecules, or particles, or we could do grams. And at this point, we don't need to make a switch because our compound already matches. And we are not being asked for atoms, we're not being asked for molecules or particles, so we're not going to use any of those. We're going to use grams because eventually we want to get to the kilogram. So we're going to do gram of aluminum nitrate. And still, our units don't match. Right now, everything would get canceled and we only have grams left over, but we're looking for kilograms. So we're going to add one more step. So we bring down the gram, and we're still talking about aluminum nitrate. And when we have gram at the bottom, we could do a mole or we could do kilo. And well, we're looking for kilo, so we're going to go with kilo. So kilogram of that same compound, but I'm not going to write it because I'm running out of space. So we have our setup. We know we're done because the very end matches. We know everything else is going to get canceled. So we now start using our resources again to fill in the numbers. So this is what we have here. We have mole and gram. So when we have mole on top, mole is 1, and gram is going to come from the periodic table. So we're going to use our periodic table to figure out what are the masses of aluminum and chlorine. So aluminum, based on our periodic table, tells us, and we're going to round it, we're going to round it to 27. So we have 27 plus 3 chlorines. Each chlorine is going to be 35.45, and there's 3 of them, so I'm going to multiply that by 3. So we get the calculator, and we're going to start multiplying that out. So we're going to have 27 plus 35.45 times 3 to get the total molar mass. So our molar mass here comes out to be 133.35. So we continue with the resources, and we see that we have mole over mole, and that comes from the coefficients. So we're going to look for the coefficient that comes with aluminum nitrate, and that is a 1. Then we're going to look on the balanced equation for the coefficient that comes with aluminum chloride, which is also a 1. So we continue on, and we have grams and mole. So when we have gram on top and mole at the bottom, mole is 1. And gram, again, comes from the periodic table. So we're going to have aluminum, which is 27. And we're going to have a total of, and remember we distribute 3 nitrogens, and each nitrogen is 14. So I'm going to multiply that out. I'm going to add that to a total of 9 oxygens. So we're going to have 16 times 9. 16 because the mass of oxygen is 16. So we put that into the calculator, and we're going to have 27 plus parentheses, we're going to have 14 times 3, close parentheses, add 16 times 9, close parentheses, and we are going to then have 213 grams. So that is what we're going to write here. The very last thing is that we have kilograms on top and grams at the bottom. Per our resources, we see that when we have 1 kilo at the top, we're going to have 1,000 grams at the bottom. So then we are going to look, make sure that everything is filled out, which it is. So then we're going to multiply every number at the top, and we're going to get a number. So we're going to do 157.3 times 1 times 1 times 213 times 1. That gives us 33504.9, and that is going to get divided by the multiplication of everything at the bottom. So that'll be 133.35 times 1 times 1 times 1,000. And that gives us 13350. We divide those two up, and that will give us our final answer. So I'm just going to use my calculator to input that information. So the first number divided by the second number, and we end up with 0.25. I'm going to round to 2 decimals. So that is my final answer. 0.25 kilograms of aluminum nitrate.